Okay, so in this section, we're going to be taking a look at matrices. So we'll actually spend the next couple of sections, I believe, working with matrices. But first, this introductory section, we're going to take a look at first what is a matrix, right? And then how to perform some basic operations. Right? So a matrix, right, is an array of numbers. Right? Just very simply, right? We say it's an array of numbers, right, that can look something like this. Maybe like this, right? Or even larger. Here. All right. Right. So in general, these are all examples of matrices, right, of different sizes. Right. When we have something like this is an example here of a column matrix, where it has one column with multiple rows, and then this is a row matrix, where we have one row made up of several columns. Right. Now, in general, right, we classify the size of a matrix by its dimensions, right? So we want to determine what a size is. There are two components to it, right? So we don't just go by, oh, the matrix has, like, let's say, for example, this one. We don't say, oh, it has 4 elements, right? When we talk about dimensions, since it's an array, we want to know the amount of rows and columns, right? So when we think of the dimensions of a matrix, we usually say it's m by n, where m represents the rows and n represents the columns, right? And that is standard notation of how we refer to a matrix, rows by columns. All right, so something like this would be a 2 by 2, right? This would be a 3 by 1, right? While as this is a 1 by 3. And then this one is a 3 by 3. Right? When the rows and columns are equal, we call that a square matrix. Right? And usually we have a tendency to use capital letters when we refer to a matrix. So we'll say something like this, right? Where A is a 3 by 2 matrix. Right? Now, sometimes it's going to be beneficial to want to name a certain element in the matrix, right? So the way we do that is, well, we refer to its position in the array, right, in the matrix, right? And the way that we do that, so we use subscripts, right? So in general, let's say I had a 3 by 3 matrix, and again, we can do this for any size matrix, right? We have this type of notation that we use, right? These A's are the elements in the matrix, and, the subscripts tell me their positions. Right, so as we can see here, right, that first number that we see there is going to correspond to what row it's in. Right, so you notice as I work my way down the row here, that first number is always, it changes from 1 to 2 to 3, even though the second number remains the same because the second number represents the column, right? So you see here when we see something like this, A, 2, 3, right? What that is referring to, second row, third column, okay? So for example, let's say that I had a matrix B, and matrix B was 1, 2, 3, 4, 5, 6. And I wanted to find A of 2, 3. Right, so I'm looking for and I guess usually it is common, it's common notation to, if it's capital B, then this would be lowercase b. All right, so B 2, 3. So that would be the second row, third column, so that element would be 6. All right, so that's how we refer to a specific element in the matrix. All right, where B represents a 2 by 3 matrix. All right, now in the rest of this section, what we're going to be doing is we want to define operations between matrices, and well, matrices and sometimes a scalar, right? So when I say a scalar, usually scalars, if A is a matrix, right? So A, B, right? They're just matrices, right? With the capital letter doesn't. Oh, excuse me, it's sloppy writing here. So A, B represent matrices. And we'll usually use lowercase letter or sometimes just kind of Greek letters like alpha, beta. These represent scalars. And by scalars, we mean just kind of real numbers. All right, now we are used to when we talk about operations like addition, subtraction, etc. We have a definition of those for real values, numbers, like real numbers, and in certain case functions, right? We define the operation of addition, right? But what we're going to do next here is, well, what does it mean to add two matrices, right? What conditions need to be met? Can I just take any two matrices and add them, right? And how would I go about doing that, right? Would the result be another matrix, right? And so we're going to set out to define what it means to add two matrices and also what it means to multiply. Now that is a little tricky, right? When we say multiply, in the sense that, well, what do I mean by multiply? Do I mean multiply a scalar like alpha times A? And how do we do that, right? Where alpha again is just some number, right? Not another matrix, but like 2A, 3A, right? What does it mean to do that, right? Notice, so we're redefining what it means to have a scalar multiplication in terms of our matrices, right? I know what that means for real numbers, but now we're going to redefine what it means for matrices and also multiplication, right? How do we multiply two matrices? What process is that like? Okay, so that's what we will spend the rest of this section going over, introducing these basic operations for matrices.